We're going to take a look at the next section in your chapter, and it is on ions, section 4.10. Ions. Anytime we have atoms that gain or lose electrons, and there's our important words here, gaining or losing electrons, and it's electrons. Remember, not protons. Protons are the personality, but electrons are the socialites. Those are the ones that like to interact with other atoms. So metals are going to tend to lose an electron, one or more, and they form what we call cations. All right, so here we have a neutral magnesium atom. Magnesium is in group 2. It has 12 as its proton number. That means it's going to have 12 electrons. It tends to lose 2 electrons. When that happens, how many electrons does it have then? Well, 12 electrons minus 2 electrons is going to equal 10 electrons, and 2 of them are lost. So what's the overall charge going to be? Well, here we have an overall charge of 0 because there's 12 minuses and 12 pluses. Here we have 12 pluses and 10 minuses, so our overall charge is plus 2. And that's how we write it, magnesium with plus 2 at the top. This positive sign right here shows you that you've lost electrons and it's formed a cation. And remember, a way to remember this is CATION. A cation has a plus sign in it and the charge is positive. So that may help you to remember that. So metals tend to lose one or more electrons and form positive ions. On the other hand, nonmetals tend to gain one or more electrons to form a negative ion. So nonmetals, remember where those are out on the periodic table to the right of the stair step, they gain one or more electron and they form negative ions, and these are called anions. So here we have a neutral chlorine atom. It has 17 protons in the nucleus, 17 electrons. That's the overall charge of 0. It gains 1 electron. When that happens, we have 1 electron. We have 18 electrons, and we have 17 protons, so we end up with a charge of minus 1. So we write it Cl minus. Sometimes it's written as Cl1 minus. All those things indicate that it's an ion and it has a charge, and it gained an electron. We're going to learn in the next chapter how to name compounds, and those that become anions, what we do once they form this anion, we would take their root name and then we would change the ending to "ide." So this is called the chlorine atom. This is the chloride ion. We don't do that with the positives, just with the negatives. All right. The ion that a particular atom will form can be predicted from looking at the periodic table. So the alkali metals, group 1A, they tend to lose 1 electron and become a plus 1 charge. So you can go ahead and take your periodic table, and above the group 1A, the alkali metals, put plus 1 at the top, or 1 plus. The alkaline earth metals tend to lose 2 electrons and become plus 2. So you can put that on top of where you have 2A or the number 2 written, put plus 2 on the alkaline earth metals. The halogens in group 7A or 17, depending on how it's labeled, tend to gain an electron and become a negative 1. And the noble gases in group 8A or 18, they have a complete outer valence shell and they don't react, so their charge is always a 0. This is a good chart from your textbook that shows this. So these form the plus 1s, and group 1 forms a plus 1. So what I would do on my periodic table is just write plus 1 here. These form a plus 2, so you write plus 2 here. Transition metals, they form various cations, so we don't worry about putting anything here. Aluminum is pretty special, and it always loses 3 electrons, so it's always a plus 3. Then we're going to talk about zinc and silver. Zinc, I think, is right here, and it always forms a plus 2. And then silver is right here, and it always forms a plus 1. But those are just exceptions. And over here in group 7 or 17, these form a minus 1. So I put minus 1 here. And most of these in group 6 form a minus 2. So we put that there. And we'll talk about other trends as we go along throughout the year. All right. An ion with a plus 3 charge contains 23 electrons. Which ion is it? All right, so let's kind of work backwards from here. Let's get that back up there. Let's work backwards from here. It's an ion. I don't know what it is, but I know that it has a +3 or a 3 plus charge. I can write it either way. It doesn't make any difference. I usually put my positive or negative sign first, but a lot of times you'll see it written like this as well. We know that with that +3 charge, it has 23 electrons. What happened to it? So if it had 23 electrons as an ion, it had to, what happened here to get a +3? Well, we must have lost 3 electrons. So it has 23 after we lost 3 electrons. So let's add those 3 electrons back. It used to have 26 electrons when it was neutral. So if it had 26 electrons when it was neutral, that means it also had 26 protons, correct? So 26, and that's not going to change, so I could have put a 26 here and a +3. So the question is, which one of these is it? And if you look at your periodic table, element number 26 is Fe, so that's what it used to be. It's Fe with a +3 charge. All right. A certain ion X contains 54 electrons and 78 neutrons. And it wants to know the mass number of this ion. And we'll show you how we get to number 133, which is the answer. All right. A certain ion, X plus, has 54 electrons and it has 78 neutrons. So we know that the mass number is going to equal the number of protons plus the number of neutrons. So we know neutrons, right? So we know neutrons will be 78. I just have to figure out how many protons I had in this number, in this element. All right, so if we have 54 electrons and it formed a +1 charge, that means it lost an electron. So all I'm going to do is add that electron back here, which is going to be 55. And if this were neutral, that means it would have 55 protons as well. So I put in 55 here, and I take 55 plus 78, and I end up with 133 as my mass number. All right, that's all this chapter is going to offer for that section. The best way to do these is to go ahead and practice on them. They get confusing. Probably the most confusing thing that I've noticed about these type of problems is that electrons are negative, so that when you end up with an ion that has a positive charge, that positive throws you off because you want to look at it and say, well, it's positive, so it must have gained. But remember that electrons are negative, so if we gain negatives, we become more negative. So if you have X with a negative number out here, -2, that tells you how many electrons it gained. This positive sign will tell you how many electrons that it lost. So just try to keep that straight. Practice, practice, practice.